Hi guys, welcome to another one of my lectures, and today we're going to talk a little bit about logic gate circuits. Now in my previous lectures I spoke about the nature of different logic gates, and as you guys may recall from your personal knowledge, the different kinds of logic gates, and each of these have a different nature. That is, they give you a different output depending on the inputs. Now, traditionally, when you merge multiple types of logic gates, you can have a sequential circuit or a combinational circuit. The circuits that we are going to look at today are combinational circuits, which means that the output just depends on the present input. There is no storage. Now, if you have two inputs, you normally have 2 to the power of n, which represents the output combinations. So if n represents my number of inputs, 2 to the n would represent my number of outputs. So here we would have our typical circuit, and one of the first things I teach my students is to identify the gates. So here we would firstly start by saying this is a NOT gate. I would say this is an OR gate, and I would say this is an AND gate. So once you've correctly identified the type of gates, the next step is to determine the outputs. So the output of each gate, I would normally assign a letter if it's not already assigned in the question. And I would notice that I have A being one input and B being another. So having 2 input means that my output combination will be 2 squared, which is 4. Now, you will be asked to have a pre-knowledge of the nature of each gate. That is how each gate behaves. So, for example, a NOT gate is an inverter gate. So if I have a 0 logic being incident, I would expect it to be flipped. So I would get a logic of 1. In the same way, if I have a logic of 1, that will be flipped and have a logic of 0. So your OR gate is an example of either or of the inputs being 1 giving an output of 1. So let's go. So we're going to look at each input combination. I'm going to fill out the table. So firstly, C is not A. That is, all of my inputs of A are flipped. So if A is 0, C is 1. If A is 0, C is 1. A is 1, C is 0. A is 1, C is 0. D is OR of C and B. So normally when I fill out the table, I like to go to my headings, I like to identify the gate, and then I like to pull relevant inputs, right? So that is so I don't get confused and do the wrong combination. So D tells me I come from C and then I come from B. So either or, now I'm looking at here and I'm looking at here. So when either or of my inputs are 1, my output is 1. So then that's 1, 1, 0, 1. Now D is selfed to go to an AND gate, which means that whatever is the input of D, it is doubled. So if D is 1, here is 1 and here is 1. So 1 and 1 would give me 1, 1 and 1 would give me 1, 0 and 0 would give me 0, 1 and 1 would give me 1. So my output gives me 1 except when A is 1, except when I have this combination here where A is 1 and B is 0. Okay? All right, next. So we have these types of gates, again another circuit, but I have chosen to do one with 3 inputs. All right, so this is the maximum you can get at the CSEC level. So if you have 3 inputs here, then 2 to the power of 3 would indicate 8 possible output combinations. And as I have always taught my students, you're going to start off with naming the gates. So this first gate here is an OR gate. This here is a AND gate. All right. Now, normally when you have the 8 output, there is a little trick that we do, right, to allow you to get the combinations. It's hard to learn it off. So what you could do is you start with 4 zeros, because remember it's either 0 or 1s, and then 4 1s. And then you split it, you go in half. 2 zeros, 2 1s, 2 zeros, 2 1s. And then you go 0 1, 0 1, 0 1, 0 1. So that way you would have gotten all of the relevant combinations. All right, so A and B. So D is the output of an OR gate with inputs A and B. All right, so 0, 0, 1, 1, 1, 1, 1, 1. And E will be D and C to an AND gate. All right, so C and D to an AND gate. An AND gate only when you have both inputs being 1, then your output is 1. So we actually have 3 conditions here where you would have an output being 1. And I have kept showing you guys that because many times a follow-up question will be, can you state the conditions where your output is 1?